Welcome to my YouTube channel. Myself Samikshar from Sri Venkateswara College of Engineering. Today I'll explain about the topic of the mathematics vector calculus. So first, introduction to the vector calculus. Vector calculus is a branch of the mathematics focuses on a vector fields and their derivatives. It combines concepts from calculus and linear algebra to analyze the multidimensional system. The field is essential in physics and engineering for modeling various phenomena. Next, definitions of the vector. A vector is a quantity that has both magnitude and also direction. Common examples of a vectors including the velocity, force and displacement. Vectors can be represented graphically as arrows or algebraically using the coordinates. A vector quantity has both magnitude and direction. Had the vector components like vector c is equals to vector a plus b. Next, vector notations. Vectors are often denoted in the boldface such as v or with an arrow. Components of a vector can be expressed in the Cartesian coordinates. In higher dimension, vectors can have more than 3 components represented as a v1, v2 and a vn. Vector notation is how we write the vectors in a mathematics. We can write the vectors in several ways, using an arrow, using a boldface and underline. Next, vector operations. Basic operations on vectors including the addition, subtraction and also scalar multiplication. The sum of the two vectors is obtained by adding their corresponding components. Scalar multiplications involves the multiplying each component of a vector by a scalar value. Next, dot product. So, dot product measures the cosine of the angle between the two vectors. The result of the dot product is a scalar and it indicates the vector's directional alignment. A scalar quantity made up of the product of the magnitude of the two vectors and the cosine of the angle between them. So, vector A dot vector B equals magnitude of vector dot magnitude of B cos theta. So, theta is the angle between the A and B. Next, cross product. So, the cross product is a result in a vector that is orthogonal to input vectors. The magnitude of the cross product represents the area of the parallelogram formed by the vectors. A vector quantity is made up of the product of the magnitude of the two vectors and the sine of the angle between them. So, vector A into vector B equals magnitude of vector A dot magnitude of vector B sine theta into n. So, n is the unit vector perpendicular to A and B. Next, surface integral. A surface integral is a mathematical concept that involves the integrating over a surface in a multivariable calculus. It is a generalization of the multiple integrals and it is similar to the line integral. But instead of integrating over a curve, it is done over a surface in a 3 space. Next, limits and continuity. The limit of a vector function is determined by the limits of its component functions. A vector function is a continuous if each of its component function is continuous. Understanding the limits and continuity is crucial for analyzing vector behaviors in a calculus. Next, derivatives of the vector functions. So, the derivative of the vector functions represents the rate of the change of the variable of the interests. So, the derivative provides the insights into the motion and dynamics of the object in a physics. So, r into t plus h minus r into t divided by h is the equations of the derivatives of the vector functions. We move on to the title. There is a curl. So, curl of a vector is represented as the n-abla times functions, where n-abla is the vector differential operator, also known as the del operator. The curl of a vector is a vector field that measures how fast and in which direction of a vector changing. The curl of a vector can be calculated by taking the cross product of the gradient operator and a vector, and also curl is used in an electromagnetic ray. Next, integral theorems. So vector calculus includes the several important theorems such as Green's, Stokes and the divergence theorem. These theorems relate the line integral and also surface integrals in a vector fields. They play a fundamental role in simplifying the calculation in physics and engineering. Next, Green's theorem. Let C is a positively oriented smooth, simple closed curve in the plane. Let D be the region enclosed by the C and F into x comma y equals to P into x comma y and Q into x comma y, a function f into u, R square C u, where u is an open region containing D. Then counter integral C P into dx plus Q into dy equals double integration dou q divided by dou x minus dou p divided by dou y into dx and dy. It is the equations for Green's theorem. Next, problems on a Green's theorem. Solve y square into dx minus x square into dy where C is a circle of a radius 2 centered in a origin. It is the problem. So, counter integral y cube dx minus x cube dy. Identify p and q from the integral. Counter integral y cube dx minus x cube dy equals double integration 3x square minus 3y square into dA. And next equals 3 into limits 0 to 2.022 r cube into dr into d theta minus 3 0 to 2 pi 1 by 4 as taken as a common and r to the power 4 limits 0 to 2 into d theta minus 3 limits 0 to 2 pi 4 into d theta 3 into 4 theta limit 0 to 2 pi taken limit and 3 into 8 pi equals minus 24 pi. Therefore, counter integral y cube dx minus x square x cube dy equals minus 24 pi is the answer for these questions. Next, Stokes theorem. So, Stokes theorem, let S be a smooth surface with a smooth boundary curve C. Assume that f equals p comma q comma r is a differentiable vector field. Then counter field C f into dr equals double integral v into f into ds. It's a Stokes theorem. Next, applications of the vector calculus. So vector calculus is widely used in physics to describe the electromagnetism and fluid dynamics. It's also find the application in computer graphics, robotics and engineering design. And the mathematical tools provided by vector calculus enhance our ability to model and analyze the real world systems. Next, conclusion of the vector calculus. So, vector calculus is a powerful mathematical tool with extensive application across the various fields. Mastery of its concept allows for a deeper understanding of a physical phenomena and a complex system. Continuous study of the applications of the vector calculus can lead to the advancement in the technology and the science. So, this is the conclusions of the vector calculus. Thank you.